Hi, if you don't know, I'm Adam Thornton. I've been working for the last couple of years on the interactive notebook aspect of the Rubin Observatory science platform, which is to say the Jupyter Lab notebook interface that you see when you go to the various LSP instances. Um, my history is somewhat varied. My undergraduate degree is in ancient Mediterranean civilizations, which I fell into after falling out of physics, after squeaking through a partial differential equations class with a C and realizing that if I became a physicist, this is what I would be doing for the rest of my life, and no thank you. Right, I like to collect and restore old computers and video games. I have video game systems from Super Pong, 1974, up through current generation stuff. The major things I'm missing are the Nintendo 64 and a Sega CD. I have most of the other systems that have come along in that while. Um, all of them acquired basically at yard sales and stuff. I like to collect things and then play with them, and do and tinker with them until they work, so I can play with them. I am not one of these people who likes collecting things because they're in shrink wrap and leaving them in shrink wrap. Similar philosophy is applied to collecting computers. I've got a wide selection of 8-bit computers from the 1980s, some Unix workstations, a PDP 11 over behind me, and a VAX 11730 right here. And I should be getting some more DEC machines, microvaxes and alphas and stuff in the next couple months. I can show you a few things about the interface, and I'll tell you some of the fairly interesting and exciting things that are coming along soon. All right, so the thing I want to point out here is that this, the Bleed version, is Jupyter Lab 2, finally. And it is mostly working. We still need to do some work on getting all of our extensions running. But that's coming along, and I would expect that within the next couple months, fingers crossed, knock wood, no promises. This is an early tech demo and is not necessarily intended to represent the final form of the product. We'll have a modern Jupyter Lab underneath this. And we've got some interesting stuff going on with both Dask for very Pythonic, low to medium scale parallel computing, and a workflow engine for sort of very simple-minded batch submissions. It's not intended to be a batch system, but it is intended to let us do continuous integration and regression testing on Jupyter notebooks, which will become really useful as we have notebooks that we want to use to show whether bits of the stack, regression testing for the stack, but in a notebook environment, which will also be helpful if we put together a tutorial package. Stack Club basically kind of is this, but we have some automated way to make sure that we haven't introduced regressions as we evolve the stack. If you have things that really annoy you about Jupyter Lab, please let me know, and we can put them on the backlog to work on. Some things like, hey, Control W exits the browser tab. Like, yes, it does. It's not going to get passed through to Emacs because the browser sees it before the terminal session does. Sorry. But, those things that we can control, we will try to make more pleasant for you. Man, the best thing about my job is my team and my manager. We work together great. Frosty is terrific to work for. I really like everybody. I think they mostly like me. We all sort of come from different enough backgrounds that it's usually possible to get somebody else's perspective on whatever problem you're having, and it's something you wouldn't have thought of. But on the other hand, we also are all generalists who can kind of step in and help troubleshoot. And Frosty has been really, really good about assembling a team of people that play well together, and it's just been a joy. This has been far and away the best team I've worked on in 30 years in the industry. So hooray.
Okay, hi everybody. I'm Suzanne Jacoby. I've been with the project since 2004, first leading the EPO planning through final design review, and now as part of the communications team with Emily, Kristen, and Rampal. This lightning story was prompted by the COM team's trip to Chile in May of 2019. We were there to document M1M3's trek from the port in Coquimbo to the summit of Cerro Pachón. It was quite a journey for M1M3 and also quite a journey for me. A journey through time, actually, looking back and remembering M1M3 growing up over the years. Here we are at the base facility, your communications team. And just a couple of the spectacular images that came from this journey. You saw these all last year and since then, but it was no easy task, keeping out of the way, not getting run over, and still coming up with these beautiful photos. Image credit, Emily. We were there for a week, and so went up to the mountain a few times and always loved seeing these beautiful tile mosaics at the bus stops. One of our trips involved a flat tire and a helpful visit from the Aura cast team, who happened to be coming up right behind us heading to Gemini. It was fun to see them there. So we are on the summit. We did make it, and our official ready to work photo, and having a little bit more fun spelling out LSST. Still working late at night on the press release here, I believe, from our home base in Casa 4. There for a week, we needed to shop and really enjoyed the produce market in La Serena. We went to the fish market in Coquimbo, saw things we'd never seen before, and enjoyed pisco sours on the beach. There was time for souvenir shopping at Rakova, and I came home with this pretty mosaic mirror because, as Kristen said, we're leaving a mirror, you might as well take a mirror. So that was a quick travel log, and here's some of the memories. In the beginning, M1M3, chunks of glass, or I should say, O'Hara E6 low expansion borosilicate. An outstanding event from the early life of M1M3 was our High Fire event, which took place in March of 2008. We had over 300 people that day. They toured the Mirror Lab, 150 guests at our evening festivities that featured Charles Simoni as our speaker, talking about space travel. The tours and a lot of the organizing was done actually by the docents. Stewart Observatory Mirror Lab docents were a great help. They were well trained by us, and they were very well dressed wearing these beautiful shirts. Here are some project dignitaries and other VIPs standing in front of the rotating oven. Some of our VIP guests, Roger Angel talking to Charles Simoni on the left, and then Don McCarthy with some Tucson area physics teachers. And some more VIP guests. Faces in the crowd include Richard F. Karras, for whom the Mirror Lab is now named. He was an early donor to our project, facilitated the first purchase of glass. Don Sweeney, George Halou. Don was the first project manager. Our evening program featured Charles Simoni, as I said. There's our model of the telescope, which I believe flew home with him in his private plane, and I'm speaking with Lowell Woods on the right. Ian and many others enjoyed the evening, especially the U of A harp ensemble. And here, if you take a closer look at the individual place settings, you will see a small chunk of LSST etched glass at each place setting. This was highly symbolic, showing that LSST, now Rubin, is the telescope, the observing facility for everyone. Everyone got a piece of glass. M1M3 continued to delight in its early life. Here's lid lifting. And on the right is a picture, I can't remember the occasion, but it's a really beautiful image showing the two different optical surfaces. Project reviews in Tucson often included a visit to see M1M3. Here's one from 2010, and in 2012, we had some happy reviewers after a cost review. M1M3 and that glass, stars of the show for many AAS meetings, which we attended in force from 2005 onward. Here in 2009, we were able to use the iconic photo of the group around the mirror. As I recall, when we set up the exhibit, there was a smudge on the mirror surface, and Tony, with an eraser, was able to fix it. 1 year or two, we were able to raffle off some leftover t-shirts from that mirror casting, and our pedometer or step counter giveaway was a lot of fun for several years, where if you had 20,000 steps on your pedometer, your name would be entered into a drawing for pieces of glass. And here you see Sydney Wolf congratulating a lucky winner. So quickly, back to 2019. This was one of the more exciting moments on the trek, on the journey for me. It was for everyone, actually, since there was only inches of clearance on either side. I'm very grateful that Javier Cortez took this picture. He's the owner of the transport company that was doing all the hard work that night. And this picture is hanging in my home office. And here we are, mission accomplished, parked on top, parked between the lines, everything looking good. So while we were waiting for M1, M3 to come over that final crest, get up to the summit, I had time to look around and appreciate this beautiful, beautiful location on top of Cerro Pachon and think about all the people and all the hard work over all the years that had made this moment possible. And more than anything, I remember being grateful and feeling really privileged to be part of this project, but to be part of this amazing facility that we've all been working on, and to watch M1, M3 grow up from a few chunks of glass to become the heart of the Vera C. Rubin Observatory. Thank you.
Hello, everyone. My name is Chris Mendez. I'm one of the LSSD camera systems engineers, and I'm going to tell you a little bit about myself. Okay, so some background. So this image here off to the right is me and my wife during one of my graduation celebrations. So my educational background is I have a bachelor's in applied mathematics. I have a master's in aerospace engineering. I've been at SLAC working on LSST now for about 2.5 years, and I was previously in a similar role for 2 years with the U.S. Navy. Okay, so now off to my interests. So 3 interests here are astronomy, my pets, and gardening. So when I was in college, I joined an astronomy club, and I put together this telescope that you see on the top right photo. On the top left, you can see the primary and secondary mirrors that are in there. And the photo of the moon here is an image taken through the eyepiece. And then down below, you can see various photos of our pets, along with my not so happy cat. And off to the left, you can see this year's veggies that we have going are tomatoes and strawberries. So what do I do for LSST? I help develop verification plans that are used to check LSST camera compliance against its requirements, and I document the as-built system along the way. So what does that mean? So I'm going to start off at the top left here. This image shows camera requirement flow down all the way, starting all the way at the top from project requirements down to the camera subsystem specifications. And so what we do with those, what I'm doing with those specifications right now is I work with the camera subsystems to develop verification plans, which essentially we use to check off that each of these requirements has been met. And so what I have shown here is an example verification matrix that collects all of this data. And this is the end result of our process, but there's a lot of planning and execution behind this. So when we go through this process of verifying requirements, obviously not all of them are perfectly met. The degree to which they're met varies, but nevertheless, we capture all of those non-compliances using our NCR system. So the best part about my job is seeing the different subsystems come together and be assembled into the camera. And the thing I'm most excited about is to see the camera level testing at SLAC. Again, as I touched on my previous slide, we're going through a large planning phase of this upcoming testing, and it's going to be really nice and rewarding to see that actually take place. And I'm also looking forward to seeing the images that are taken later down the road on the summit. And that is my talk.
Hi, let me tell you a quick summary of my history with the very Rubin Observatory. About 10 years ago, in August 2010, I was about to finish my PhD in physics at the Federal University of Santa Catarina in Florianópolis, Brazil. The city is in an island in the southern part of the country, surrounded by beaches and Atlantic forest, which is different from the rainforest, by the way. My PhD was mostly dedicated to stellar variability, and that was about the time me and my colleagues heard about the Large Synoptic Survey Telescope for the first time. Needless to say that we were all very excited about the project, and one of my first thoughts after learning a bit more about it was, one day I will work for that project. Time passed by, I finished my PhD and went to work in Chile at SOAR and got to know even a bit more about the project, including the site itself. I left Chile a couple years after that and started a professorship position at the university in the northeast part of Brazil, in a city called Aracaju. The name is a mix of the bird arara and the fruit caju, or cashew. And for those that don't know, cashew is a delicious fruit and is much better than the nut. At this time, I started working on a collaboration between four universities in Brazil in a project called S+, which involved the construction of a robotic telescope in Chile. I was initially in charge of the survey scheduler, and later started to work uh, a lot on the observatory control software, system integration, and commissioning. In 2016, I learned about the scheduler scientist position at LSST and thought that was my chance to fulfill my long-lasting dream of working for this marvelous enterprise. And ever since I started working in the project in 2017, I could see history repeat itself. I started working with the survey scheduler and later started to get involved in observatory control software development, system integration, and commissioning. My name is Tiago Ribeiro, and today I work as the software architect for Telescope Insight. As the software architect, I try to make sure the observatory control software not only meets the requirements on paper, but also the user's needs. The most exciting part of my work is making sure we can go from this to this, and eventually to this. Thank you.